Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Everybody welcome. Great to see all of you. I have a special treat for you. So listen, we're advancing AI. We're building a new industry. We're revolutionizing one application after another, one industry after another. Every application will be powered by AI. Every country will build it. Every company will use it. It is the case that we spend a lot of our time talking about the frontier AI models, the frontier AI labs, the proprietary ones, and they're super important, and they're essential. They're, in a lot of ways, the foundation that got everything going. However, beyond all of that is a rich diversity of what AI is, a rich diversity of how AI models out to be created, and rich diversity how AI models will be integrated into applications. I have a special treat for all of you today. We're going to have frontier AI labs that are building the beyond all the things that we talk about, spend most of our time talking about. The one statistic I will say is that the open models, and we're going to talk a lot about open models. There's so many different types of AIs and different applications of it. It's really great to expand a horizon. The open models in aggregate is probably, well, is already the second largest model in the world. In aggregate, my sense is across all of the different industries and different applications will likely be the largest model in the world. And all of these things are not A or B. You know, it's not one model versus another model, but it's a combination of system models. And you're going to hear a lot of different perspectives on that. And then today, we have two sessions. We have so many great speakers for you. We broke it up into 2 sessions. And I have the benefit of just hanging out like all of you. My work is done. This is it. My work is done right now. But we are going to talk about the what, hows, you know, wheres, beyond the frontier AI models. And to join me are some amazing CEOs. Oh, by the way, I got a new jacket. What do you guys think? That's the Cursor logo. Nvidia uses a lot of Cursor, and all of our software developers have AI assistants. And so right now I'm wearing Nvidia employees on my back. Okay, let me welcome some amazing CEOs. Harrison, come on board. This is Harrison Chase, CEO of LangChain. 1 billion downloads, you said here. Mira Murati, CEO of Thinking Machines Lab. Nice to see you. Arvind Srinivas, CEO of Perplexity. Before anybody understood what agents were, Arvind was building them. Michael Turrell, designer of leather jackets, CEO of Cursor. Misha Laskin, CEO of Inflection. Nice to see you. I think who's the youngest company here? I think it's got to be Misha, right?
Probably, yeah. 2 years old. Oh no, maybe Mira's company.
Yeah,
okay.
Just over 1 year.
Wow.
Yeah.
Well, who's the oldest one here? I know, but aside from me, the longest. Who started first? Arvind, LangChain. You guys were all pretty close.
One of you guys.
No?
We started open source a month before ChatGPT, but I think you guys were around.
Yeah, I guess we started August 2022. So
we're an elderly January 2022 vintage. So
okay, Cursor.
Okay. Well, so hey, let's get right to it. I think obviously We all love OpenAI. We all love Anthropic. We all love Gemini. We all love xAI. We love the work that they do. There's a world for proprietary models. There's a world where models as a product should exist. Models as a product. Remember, models is a technology, just as transistors is a technology, not a product. It's a product to TSMC. To me, it's a technology that we integrate into other products. You guys understand that, just my definition of technology and products. So in a lot of ways, open models is a technology. ChatGPT is a product. Okay, that's my definition. Is that okay? And there's a world where we love a world where there's proprietary products, but we also need a world where a whole bunch of companies in different industries, in different domains, need models as a technology that we could then transform into products. But before I go there, the first thing is, and the rules. Hey, you know, a lot of moderators that do this, they ask a question, they go, okay, and then the next question goes to you. Can we do this? Can we just not be polite? Can we be like, this is at my house? Can we do it that way? Okay, I'm just gonna lob a question, I'm gonna put it right there. That question lands right there, and whoever wants to just answer it, and you guys are welcome to speak over each other, and then, is that okay? Can we do it just like at my house? Can we just, okay, all right. And we need this to be super high bandwidth, and just you know, do like you always do, just talk over each other. Yeah. just like normal, okay? That's what CEOs do. Okay, all right, so anyways, the first question is and the first area of topic is remember what a language model is and is not. For a long time, and of course this audience is much more informed, a lot of people think that AI is the large language model. That in reality, AI is a system of models and system of a lot of other things. And to create all of those other things for different domains requires an enormous amount of other technologies. And so today, really what I wanted to celebrate is not the proprietary versus open, because I don't think that that's a thing. Proprietary versus open is not a thing. It's proprietary and open. And we love the fact that they're these terrific models that are really products, but we want to create the rest of the system and the rest of the ecosystem, which allows us to address the rest of the world. And so maybe as a starting point, you know, the first question for you is what do you think, based on and in addition to everything that I've said, what are some of the misconceptions about large language model companies like OpenAI versus the rest of the ecosystem that are thriving, that are existing, that are really doing incredible work that people don't understand or miss?
Well, first let me say that I am excited and genuinely a little bit nervous to be participating in a ritual that I've heard from NVIDIA employees of the Jensen meeting. There are many long tenured, some of them have been at the company for 2 decades, incredibly brilliant engineers and executives that we partner with at NVIDIA. And when the idea of the Jensen meeting flashes across their mind, you see them shudder a little bit. And so I'm glad that we all get to participate in that and see that. But on your question, I think that
because I ask good questions, you guys, we get the channel. We're gonna channel Jensen meeting here.
Yeah. To the question, I think that folks think that there are only 2 types of companies up at the software level of AI. I think that they think that there are foundation model companies that build very large general models, sell access to those models through APIs, do lots of products in different verticals. And then there are application companies that don't really do much AI work themselves, but they build great products on top of the models. And I think that we are really seeing the birth and flourishing of a third type of company that sits in between the 2. A company that uses the best the market has to offer at an API level, but then also does great work on the modeling front too, and takes both the best the market has to offer on an API level, their own models, and wraps them all into one, into the best product for a certain vertical. And in particular, I think we're seeing the rise of a new type of agent happening over the course of the next year or two, where the way you used AI models, it started as you're just calling a model. And then it got a little bit more complicated. It became calling a model, and that model has a bunch of tools that it can use. And I think we're soon going to see agents really be coworkers that can take on tasks that take many hours or many days and do incredibly complex workloads. We've experimented with things in this domain in software, where we've experimented with building, for instance, prototype browsers from scratch over the course of many weeks, entirely end-to-end with agents. And when you start to get to these much more complicated workloads, under the hood, you want to be farming out that workload to different models, because different models have different strengths. And there are going to be times when you want to use the computer use abilities of a foundation model from one of the APIs, and there's going to be other times where you want to use the industry-specific intelligence you have as a company that's focusing on one domain to farm out your own models. And so I think we're going to see the rise of these compound agents that can be smarter than any one model on their own and mix them all together.
Can I go next?
You didn't ask my permission, Mike.
Okay. So, how many of you have heard of Perplexity Computer? Okay. So that's easy to explain now. As Jensen said, AI is not the model, it's the system. It's the computer. Perplexity Computer is the idea that you should build the orchestration system of everything AI can do. Every single capability, coding, writing, generating multimodal content. So what you want is a multimodal, and obviously multi-cloud orchestra of every single tool, model, file system, connectors put together, so that all you got to do is delegate your task. You don't have to worry about which model is good at what. It's for the orchestration system to figure it out. These sub-agents are like musicians, and the models are just instruments. And the work that AI gets done for you is the symphony or the music that they play. And that makes it all pretty simple. You get to basically think of any task that AI can do today, any different model. You don't have to feel any vendor lock-ins. And just Jensen was saying in the beginning, it doesn't have to be a dichotomy between open models and closed. We have open models in computer. We have closed models in computer too. And there are different needs for each of them. Open models tend to excel at being very token efficient, cost efficient. Closed models are very good at orchestration, reasoning, tool calls. And basically what's happening is models are essentially becoming just tools like file systems and connectors. And we're able to operate at an abstraction above models, finally. And so that's what I find very exciting, and I think I'm basically just echoing whatever you said at the beginning. But productizing this and running all the workloads that enterprises need on a daily basis is basically what we want to make happen.
There's this new term called harness engineering, where we're seeing a lot of effort go in terms of developers when they're building these applications. And harness engineering is basically everything around the model, how it connects to things. And there's a lot of different choices you can make: when to compact, what subagents to use, what models to use in those subagents. Do you support skills? Do you not support skills? And I think maybe one misconception is like, even the closed labs are doing this all the time. You look at Claude Code, sure, the model's great, but the harness around that model is really great as well, and that's really impactful. And so we spend a lot of time talking to developers, thinking of how to build a harness that's just right for the environment that they're in, and that could be many different models, that could be file systems, computers, but this harness engineering is a new thing that we see coming around the bend.
That's right.
There are two kind of big misconceptions that I think exist with model companies broadly. The first one is that model companies are not actually model companies. Like, they don't just build a model, they build a whole stack end to end. So when you're buying a model from a proprietary or otherwise, you're actually buying the chips, this orchestration software, the inference, and product, and all of that has been optimized end to end. Now, that yields great products. And what openness allows is for other people to basically optimize the whole thing end to end. So you're not just buying a model, you're buying a whole system. I think the other big misconception is on open models, that somehow open models are fundamentally going to be behind the frontier. That the hit that you take when you adopt an open model is you get control, but you get something that is a few months behind. I think that's just a artifact of the time where we are today. There's nothing fundamentally different between an open and a closed model. And models in general in this system, it's fundamental knowledge infrastructure. And fundamental knowledge infrastructure yearns for openness, like an animal, yearns for the hills or for the forest. Like it wants to be open. Like books used to be closed, and the printing press made them open. Science used to be, there were alchemists, and then the scientific journal made it open. And strong encryption, there was a debate between closed and openness, and actually it ended up being both. It started out closed, and then there's a whole flourishing ecosystem of strong encryption that became open. And I think the same thing is about to happen in AI, where there's a flourishing ecosystem of powerful closed models, but equally capable open models that are going to be coming over the next couple of years. And I think that's really exciting.
One last thing I would add is that progress is extremely fast. We are on exponential, and everything is very compressed. And there is a lot to learn. There is a lot of study to be done, and it cannot be done completely in the large labs because there are tons of smart people out there, but they're lacking access to knowledge, access to tools, and this is where openness can be very helpful. And it doesn't have to be just models, also infrastructure, data, general research insights, and this can enable a ton of people out there that can study various aspects of research, and it advances the science of AI, science of intelligence. I see it as very positive sum. And there is this misconception that openness can be negative sum, and it can be negative for commercial progress and so forth. And I take a different perspective. There is a lot of nuance, and there is timing. There is, you can make a lot of decisions with what you actually release. And one of our early decisions as a company was to release an API for post-training and finally make it accessible to many researchers out there to do post-training, like in the frontier labs, on top of the open models. And I think we've already seen how much new research this is creating and accelerating, and my hope is that the openness ecosystem can really advance AI research.
Yeah, there's just so many dimensions to the work that we do. A lot of misunderstandings about how these large language models come about. We talk about pre-training. Pre-training is memorization and generalization and some basic knowledge. That basic knowledge gives you the foundation to go learn skills. If you didn't have that basic knowledge, you wouldn't even be able to teach. I mean, you can't teach someone how to be an engineer if they don't have any basic skills in math and science and some basic understanding of technology. And so the pre-training part was just the beginning. Most people misunderstand that, in fact, all of your labs do enormous amounts of model development, particularly in post-training. And the post-training area, if you were to think about the amount of computing scope in the future, the amount of computing use in pre-training was like 90% of training 2, 3, 5 years ago. But in the future, the amount of training percentage in pre-training is probably going to be tiny. It's going to be mostly post-training. It is also probably the case that these proprietary models are going to be the best generalists. But it's very unlikely they're the best specialists. And most value is derived from specialists. I mean, we need generalist capability all the time, and they're going to get better and better. And as you say, when we integrate them into a system, you get the benefit of an insane generalist as well as an incredible specialist. That's the why it's not about it's not about a tyranny of ors. One of the things that is happening, and Mira, you said that we're going through an exponential. But the really amazing thing is witnessing it from the inside. We went through 3 transitions now. The first one, of course, generative AI. Generative AI People, were amazed by the images that it generated. But without generative, you can't think. There's no reasoning capability if you can't generate tokens. You have to generate words, you have to generate thoughts to be able to reason. Internal generation, if you will. Without generative, you can't use tools. And so generative AI, that first foundation was really important. Then we went to reasoning, O1, and of course the third inflection now with agentic systems. The part that is really interesting that I am observing is that we're watching the technology go through an exponential, but the end markets are going through an exponential. This is where the applications finally have reached a level of capability, for example, Michael, with Cursor and with coding software. But this is happening in so many different domains. It's going through exponential. The amount of AI funding into AI natives at the application layer is completely explosive. What was the inflection that you guys saw? I saw what I saw. What were the inflections that you guys saw that's made possible for AI now to be useful at an application, industrial application level? What are you guys witnessing?
I think this is actually going to be before language models. The first inflection point that I believe, at least I saw, that basically made me switch from theoretical physics to AI was a system that my co-founder Yannis helped build called AlphaGo, which was the first super intelligent agent at scale. And it was a 60 million parameter network. It was tiny relative to what is now. And it beat the best kind of player in the world at Go. And the thing is that that system never stopped learning. It was just an economics problem of how much compute are you willing to put in to get it to be 10x better. And at some point they cut it off because, would you put $10 billion more to make AlphaGo beat Lee Sedol even harder? Probably not. But now that RL has started working on language models, those are the kinds of questions we'll be asking now, in a year from now, of am I willing to put in $10 billion, $100 billion to solve, to cure a particular disease, When you have RL working at scale, the things that you can solve, because these are mechanical brains with endless capacity to learn, become just a matter of economics. And we're seeing the first generation of that in coding and agentic kind of enterprise applications, but we will be coming to a point where there's kind of fundamental scientific problems, and we're just making economic decisions of whether we want to allocate those resources to have a breakthrough.
Yeah, I think that the economy-wide story of AI last year was coding starting to work in a big way. Yeah. Coding agents and end-to-end coding automation. And we're deeply, deeply, deeply focused on coding, and we think that that market has a long way to go in both the value that can be given to end customers and how far the technology can be pushed. And so there's lots to do to create the true promise of you can build anything you'd like on a computer and it's end-to-end autonomous. But I actually think that the economy-wide story of AI, and you mentioned inflection points, this year is going to be what started working in coding last year is going to work in all of these other domains. And it's been amazing how much demand and commercial interest there has been in AI in 2023 and 2024, when there really have only just been a few markets that are really at scale. And I think that this year, we're going to see that proliferate across a bunch of verticals. And I think that the personal productivity agents growing incredibly fast, while the products are still very early and immature, things like OpenClaw, for instance, are just the bellwether of that. And I think that that's going to continue throughout the year.
Yeah.
Maybe adding one thing there, I think one thing we're seeing in the general purpose market is that a lot of these agents look very similar to coding agents in a lot of regards. There's a lot of things that coding agents can do that are general purpose. You can write code, and that can help solve sending emails, for example. And so I think specifically what happened in the agentic market is there's this, for the most part, there's this simple idea of what an agent is.
Almost all work could be specified as code.
Exactly.
Almost all work could be specified as code. That's the reason why it's so important. Go ahead. I'm sorry.
And so there's this simple idea of kind of like an agent, an LLM, running in a loop, calling tools and executing. And the coding tools are actually, like, as you said, very general purpose. And I think I think up until maybe about a year ago, that simple algorithm, and simple's great, like simple's great, that simple algorithm didn't really work. And then it started to work because the models got a lot better. We started to figure out what tools to give this harness, how to get it to work. And so I think this year, when we see all these other domains take off, they'll take advantage of the models getting better, and they'll take advantage of a lot of the tricks we learned about the harness to put around these models to make them work for coding, and we'll port that to other domains. But there'll still be a lot of similarity between like coding harnesses.
Yeah. So I guess models suddenly start, I mean, I guess you could say with R1, O1, and particularly O3, models started being good at native tool calls. So the rest of the ecosystem started organizing around tools, MCPs, connectors. And towards the end of last year, models started being very good at using files and CLIs. And this whole concept of compaction is suddenly very important. And ability to just orchestrate a system around files and command line. So you give it a console, and you can pretty much do everything. So that's actually the reason why coding is transferring to the rest of the world, is because a model that was particularly built to be very good at operating a console, a code execution sandbox, can suddenly do almost any work that you do on a computer if every tool is available as a command line interface. So I feel that it's such a simple idea in hindsight, but because of that, now everyone's making their system a CLI. Okay, great. So almost all the work that you would do otherwise on a graphical user interface, you're now doing it on a code execution sandbox, and therefore a model that you originally trained to be very good at coding is suddenly able to do all kinds of knowledge work, which is why what matters now is the computer, the orchestration system.
That's right.
I would say ChatGPT brought AI into the public consciousness, and coding really spiked up the usefulness.
Yeah. Yeah. One of the things. So Misha said something that's really important earlier. Remember, back in the old days, we said that intelligence is directly correlated to the amount of data you have. In fact, intelligence is actually correlated directly to how much compute you have. And these algorithms that runs on top of it. And I'm saying that for my own benefit. And Misha said earlier, if somebody was willing to invest $100 billion, I was going to jump in and just say yes. But I wanted him to finish. But that's a very important concept. Another super important concept, and this is an area where I'm waiting to see how it's going to develop. Are the applications going to increasingly become CLI enabled, or are the AI models going to become more able to use tool use that are designed for humans that are very unstructured? The environments are quite unstructured, and so my sense is it's probably going to be both converging at the same time, right? And you guys are going to create AI models, I hope, that are multimodal and that can understand the unstructured, messy way that applications are used. Yeah, one of the things that you also said, Mira, that was really interesting, that most people didn't realize, in the case of ChatGPT, the technology was sitting in plain sight for some time. You guys remember that? It was sitting there for, I don't know, 6 months. Yeah. And then all of a sudden somebody put, if I could reduce it down to something that I really, really hate, a wrapper. Do you guys remember that? You guys were like all wrapper companies, like Cursor. You were like the first wrapper. And I don't mean R-A-P-P-E-R. You know what I'm talking about? Back in the old days, oh yeah, these are wrappers, okay? They forget that, in fact, AI is a system of really complicated things. And that was described as a wrapper in the beginning, which really understated the incredible importance of. But ChatGPT was, in fact, a wrapper around GPT. And in a lot of ways, the reason why people didn't see the agentic era coming, and it's been sitting in front of us, is because the first application of agents were enterprise. And only we were experiencing it. Most of the world, most consumers never got the benefit of experiencing agentic systems until recently. But before I ask the question though, hey, Madison, I didn't get the protocol. What clocks am I supposed to look at? It's counting down? And am I supposed to stop at 0 for this session?
Is it already 0?
No, it's at 29. See, my problem yesterday, so 2 days ago, I gave a keynote and I lost track of time. And I was gonna like, hang on a second, is this supposed to end at 5 or 3? You guys know what I'm saying? And so today I said, note to self, no, is it counting up or down? What's happening? I have 10 minutes? There's nothing on that clock that says 10 minutes. See, this is what happens when we don't rehearse. So I was walking off stage, and the audience on the right-hand side, they just went crazy. They said, Jensen, you don't use a teleprompter. Apparently, they said, there's no teleprompter up here. And so, what? Now it's at 0. What happened? Guys, this is why you practice. We just grip it and rip it. Well, you guys are CEOs. Okay, so this is what I recommend you do. Don't allow your company to get so lazy as to not write your script. Okay? So if I were to rebuild this company from day one, I would set that as an expectation. Because other CEOs, they got like teleprompters spread all over the stadium. Do you guys understand what I'm talking about? And they don't even have to get ready for GTC. They just show up and read. And like all these people write, I've got to get on stage and figure out what to say. And so the problem is sometimes you guys could actually see me thinking. Sometimes I'll pause and it's like, why is he talking so? I'm trying to write the script. And my token generation is not as fast as it used to be. Okay, so I'm about to go to 10. Is that the idea? Okay, so it turns out that agentic systems, from a technology perspective, went through an inflection. There's no question about it. Would you say? And really, my first experience with agentic systems was Perplexity. And Arvind gave me one of the first access to a Perplexity computer, and he keeps asking me whether I've been using it. Unfortunately, I've been like getting ready for GTC, and I haven't used it as much as I wanted to. But I gave it some projects, and I got to tell you that there's no question, it's a big deal, and all of you ought to try it. Everybody ought to subscribe to it and pay the maximum amount. But
the maximum amount is unlimited, actually, because you can actually just pay for tokens after you cross a certain limit. So there is no limit. You can spend as much as you want.
Okay, so I agree with him. And so anyways, and then all of a sudden it came. And all of a sudden it came, and we'll start with Mirror. All of a sudden it came. OpenClaw drops. OpenClaw is a big deal, as you know. In a lot of ways, OpenClaw is bringing agentic systems to the consumer mindset that ChatGPT did. Of course, it's not as easy to use. You got to build it, but at least everybody's talking about it. So my first question to you guys is this. What do you think is what is OpenClaw? I've got my perspective on it. Why is it important from a computer science perspective? Why is it important from an industrial perspective? And let's talk about where do we think it's going to be in a year?
So models, in their own right, are like not very useful. They're like brains without bodies. And OpenClaw, and there have been multiple iterations that kind of led up to this. There was, I remember, an early project called AutoGPT, and there were various kind of agentic projects. And what happened is that the model capabilities caught up, and the harness was calibrated correctly to the model to make it actually useful. And this is effectively gave the brain its limbs into a computer. This used to be kind of a question that in research labs you'd ask the questions of what is the right action space for my robot, effectively, right? What is the right morphology? And OpenClaw discovered effectively the right morphology for the models as they are today. And it will likely evolve a lot because the models are moving very quickly, but it's kind of a working stake in the ground from which you can start incrementing upward.
Yeah, I'd say the model is a source of generality and general capability, and we've made huge leaps with model capabilities, and whenever we'd make a big leap, it would unlock a lot of usefulness. And now we're at a point where models are extremely capable. And in order to unlock usefulness, you need to work on these orthogonal capabilities, connecting the context, being able to operate within your data, within what you're trying to do in your domain. And this is an example of that, having an agent that sort of can operate in your domain, within your data, connecting everything together, building this system that's more of an operator. And we have a long way to go to actually make this very reliable and take actions that you want to do with the intent that you have. But it sort of like shows that capability and where we need to go in terms of unlocking more usefulness.
I think OpenClaw is an example of people seeing what started to happen for professional software engineers last year happen for many other folks. And that's the transition of AI from something that just answers you to something that takes action. And I think that this stuff is going to get so much better over the course of the year. The products are going to get way more mature. The models and the systems orchestrating the models are going to get much more capable. And so you'll be able to have personal productivity agents that can take on more complex tasks that run for longer. And I think that also, these compound agents, they will get much better at using tools. And there was a discussion before about the ability to write code has kind of unlocked these non-professional SWE use cases, for instance, like OpenClaw, which writes code to use tools on a computer. But I actually think that that's a little bit of a shim. And I think that the models will just get good at using computers entirely end-to-end. And the tasks that you do on a computer, you'll be able to have models help you with them. And so all of these and many more, they're going to stack over the course of the next couple of years. And agents, which are so early in their stage of maturity, yet so popular in professional software engineering, they're going to start to exist for personal productivity and get really mature too.
Maybe calling out kind of like 3 interesting things we saw in OpenClaw. One is the fact that it's always on. It's proactive. It's messaging you. And by the way, this is great for open models as well, because if you run an agent like once a day, great, you can pay more. If you're running it every 10 minutes, you really care about cost. And I think this is where open models can be really, really impactful. 2, I think we saw the idea of this like identity of an agent come about. I was talking to one SaaS provider, and they ended up making it easy for people to create seats in their plan for agents because they wanted their agents to have access, but they didn't want them to have the exact same access that they had because they were exposing it to the outside world. And so I think this idea of agent identity is a new thing that OpenClaw kind of like brought about. And then third, I think, is like these memory that these things have. You interact with it, it kind of remembers it. It can edit its own instructions via code. I think that's a big part. I would consider that part of its memory. And so I think in addition to everything that they said, I think these 3 things were like really interesting to see, and I think the first time we saw them at scale.
And I'm going to ask Harrison a quick question. You're going to have the last word, okay? And so Arvin, as you guys know, he built this thing called Perplexity Computer. In a lot of ways, OpenClaw is a computer, and it's a personal artificial intelligence general computer. And I'm going to give you the last word. But the thing I wanted to say is this: OpenClaw is also an agent, and what LangChain does is build agents. And so why do you need LangChain to help you build agents if you already have an open source agent that's already so good? And so I want to give you the opportunity. I can explain it, but I want to give you the opportunity to explain, because if he doesn't do a good job selling LangChain, I'm going to jump in and help him sell LangChain. Because I'm their best wingman, every one of them. I'm every one of their best wingmen. I gotta tell their story all better than they can. Anyways. These are some of the finest CEOs in the world, some of the most amazing companies in the world. So anyway, Harrison, jump in there.
I'm going to do a bad job, so you have
to. Yeah, I'll mop it up.
We think there's going to be a lot of different agents out there. We think, as we were talking earlier, there's going to be agents that do legal things, agents that do sales, agents that write code. And so we think that all of these agents, they'll be powered by a bunch of different models, and they'll have different harnesses with different tools and different capabilities. And so a lot of what we build is the tools to make it really easy to customize those harnesses to the verticals and the domains for which you want a production-ready agent.
Yeah, I thought you did a really, really good job. I just hope they understood it. And so here's the thing. OpenClaw, of course, is a very, very capable general agent. It is the case that in most of our work, having many specialized agents is still essential. And those specialized agents have to be put into a flywheel inside your data center and inside your company to continuously learn. It has to be put into a, if you will, environment that you call harness that allows it to perform its job. And each one of the harnesses or each one of the environments of the specialized agents may be different. Now, you could always create the super artificial intelligence, universal, everything agent, but it's unnecessarily expensive, it's unnecessarily, slow. And that's one reason, to create these sub-agents. And the second reason is you're going to have systems of agents. And these systems of agents, you may decide that the work is so well understood, and you want it to be done exactly this way. You don't want it to be done any other way. You don't want the general agent to go figure out exactly how to do it. You want to prescribe it. And that system of agents could be in sequence, in serial, it could be in parallel, it could be serial in parallel at the same time. And so you might be rather prescriptive about it, and LangChain allows you to orchestrate that as well. And
if you're looking for a job, we're hiring on our marketing team.
Is that right?
Yeah.
Okay. Well, this one, this shtick might not work out, and so I'm always interviewing. I'm just okay. Irvin.
Okay.
Close it off for us.
Sure. I think OpenClaw or whatever other products, Flexi Computer, Manus, Cowork. I think the fundamental idea is computers are cool again. These are all, as Jensen said in his keynote, it's a new kind of computer. And the runtime is GPUs. Okay, so token king. So we're all going to be spending a lot of tokens on a GPU runtime. Our computers are way more powerful than the kind of PCs we use. Though PC also could mean Flexi computer. Yeah, I'm really excited about this future. I think it's going to be a lot of hybrid local and server-side compute. And even the local compute could have a DGX Spark-like system that has the agent orchestration loops running locally for anything that has to use your local files, local apps, and a lot of server-side runtime that runs on GB200s, GB300s, doesn't matter, right? Or
Arvin, I'm doing fine.
I'm here to. I was asking Corby for a bunch of them, but, hopefully you can give me some. But yeah, I think that's the future. We're building a very new kind of computing platform on top of GPUs that's going to run our businesses, our lives, and let's build it together.
That's cool. All right, guys, thank you. Thank you. All right, good job. Okay, don't go far. You're going to have to come back out. Don't go far. Good job. Good job. Misha, good job. That's why, now you guys know why I love these guys. All right, we have the next team, the next crew. I think you guys go off this way or that way. This way or that way. One of two choices. That way is not suggested. What? Now my clock is counting up? It's gonna, really? Okay, all right. It was counting up, down, and sideways. All right, we're on track. We're on track. Okay, next. So don't forget where we ended up. This is the artistry of me asking questions. I set the foundation, otherwise known as context. I gave them a prompt. Okay, and notice the long rollout. Not one person understood that word. The long rollout without intervention. Did you notice that? I was saying if I could prompt it just right, I bet it could go all the way. and everybody could add value to the context and the prompt without my intervention. However, the only way to make that possible is that the general agent, me, is sufficiently intelligent with the support of sub-agents that are super intelligent, that the long rollout was possible. Did you notice that? I know. Okay. Now that puts a lot of pressure on my new sub-agents. Ladies and gentlemen, come on, Arthur, come on board. Arthur Minch, the CEO of Mistral. Come on. Sit down. Come on. Daniel, the CEO of Open Evidence. Thank you, Daniel Nader. Hannah, come on. She heads research for AI2. Nice to see you. I took pictures with Hannah long ago when, well, not that long ago, long ago, well, she had a baby, and it was at CVPR, and we took, and that's got to be 10 years ago, right? 9 years ago? Wow, that's incredible. All right, that's incredible. Robin, come on. Robin, CEO of Black Forest Labs. Previous Nvidia intern, I raised him. Anj, come on board. A venture capitalist extraordinaire, now the CEO of a company called AMP. All right, guys, I explained earlier my role, which is to present context and then a prompt. And your job is to roll it out, okay? And without any intervention from me. And that's, I set the conditions, and everybody's gonna be observing this. And so if you guys like pause, like one person, and we're gonna do this like at my house, you just talk over each other, okay? And I know that for some of you, you're better at it than the others, but now I'm gonna ask a question, but when it comes, Arthur, when you start to talk, remember, none of these people understand French, okay? And so now that I said that, he's going to be speaking English. I promise you, you would have no clue what he's saying because you still sound like French.
I will show you. Yes.
Yeah. His
for sure.
His baud rate is his baud rate is 5 times mine, and my comprehension rate is 15% of that. And so. All right, so just now we ended at OpenClaw. And OpenClaw is a big thing. It's a very big deal. It is the most popular open source project in history. It happened in just a few weeks. It presented the capabilities and the vision of what agentic systems are to the world. And in a very sensible way. Of course, it would be this way, that an agentic system that is able to understand, reason, and perform tasks would be presented in a lot of ways like a computer. That it would obviously have working memory and access to file systems. Obviously, it would be able to schedule tasks. Obviously, it would be able to interact with I/O, have input, network with other computers. Obviously, it would be sufficiently general purpose and therefore a sense of an API, if you will. Skills are essentially the ability for it to run many different types of applications. And so that in a lot of ways, OpenClaw is a representation of the modern computer. When I say we've reinvented computer, OpenClaw is actually the perfect representation of it for the first time in a complete system, completely open. It's definitely a new computer. There's no question about it. So now it's dropped. In China, there's claw mania. You guys know this. People are raising lobsters. Their lobsters are interacting with other people's lobsters. The lobsters. Everybody's raising. You guys know this, right? Okay, you got to stay alert, guys. Okay, the most important part of being CEO is you got to stay alert. And so they're raising lobsters. Lobsters are having friends. They get together. The lobsters are creating lobster companies. The lobsters are going out getting jobs. Okay, and the jobs have to pay well enough to pay for the tokens. I actually heard somebody's lobster consumed 50 million tokens in a day. At $1 per million tokens, that's $50. And so that lobster's got to go out and at least get a job that pays more than $50. It's got to pay $51 to stay alive, you know? And so, but this is all happening right now as we speak. Now, my question for you is, what is the implication at the industrial level? What is the implication at the industrial level? In the verticals that you guys work in, theorize about all of the verticals. Think of healthcare, for example, very, very big deal there, I think. And so what is the industrial implication of OpenClaw and the presence of the first open source, very capable agentic system?
I'd say what that shows is that at an individual, sorry for the French accent, but what that shows that at an individual level, you can delegate a lot of tasks to an AI systems.
Pause a second.
Yeah.
How many words did you just understand of that?
It'd be very hard.
I'm sitting next to you. I caught 3 words.
Oh.
I'm just saying, if you want them to understand what you're saying, you got to do it different. That's my reinforcement learning algorithm.
So I would say at the industrial level, the problem is that you have you want to have workers that are actually delegating tasks, and suddenly you're in an organization. So you have a lot of data problems, governance problems. You need to think about how the organization is going to be transformed around that. So suddenly the bottlenecks you run into are way more complicated than the bottlenecks you have when you're just an individual. So that's the kind of things that we actually do when we work with enterprises. You need primitives to have the right governance, right observability, to host everything in the same control plane. And that's actually a bit harder than just buying a computer and setting up OpenClaw on it. And it's actually a lot of value creation for enterprises if you make it right.
Yeah, and I promised I wasn't going to do this, but I have to do this. Okay, I promised I was not going to interrupt until the rollout completed. And so, but unfortunately, I am certain you heard every word, you understood 7 words, and conceptually, what Arthur just said is a very big deal. I just want to say it in human words. Can I do that?
Please do.
Okay. So it turns out an agent does 3 things. It can access sensitive information or sensitive information, and it can execute code, and it can communicate externally. If we want to be secure as a company, as an enterprise, you should allow someone, including an AI, 2 of those 3 things at one time, but not all at one time, except unless it's the CEO. Access to sensitive information, execute code, and communicate to the outside. Notice, I just described that the reason why I'm allowed to do that is because, you know, like I said, I'm the CEO, okay? But otherwise, most of the other agents in the company should be allowed 2 of those 3 things, but not all. But at all times, all of it should be governed. So governance, security, policy, compliance, and access, right? Secured access, approval of access. All of that is incredibly complicated. And now we have agentic systems. We have the software that's going to come into enterprises. All of that's going to come into play. And so what Mistral does is help companies be able to do this, and it's just really important. He's going to come back to it. But aside, I'm going to jump off. Go ahead. Roll it out. Roll it out.
I can say something. So everybody talked a lot about a lot of great things that we can achieve with OpenClaw. One important point that I like to mention is being able to handle privacy trust and control over the data that we have. So for all these agents that we are using through OpenClaw, we expect that they have access to all my data. So how much comfortable I am to let these agents to rely on my data, to my personal email and so on. And I would argue the role of open model is very important in this world because I feel more comfortable letting open models access my private data. So privacy, security, and control is a very important piece here.
Yeah, I think I actually want to take it a little bit away from like the pure agentic focus here, and because I think like a lot of the like progress that we're seeing in like OpenClaw, etc., is because these models are becoming so good at code. Code is like verifiable, but I think there's many more frontiers besides just code, right? One that we are working on is visual AI, visual intelligence, and I think for that, like everywhere where like a robot or an agent interacts with the real world or with a human, visual content is actually pretty important. Like understanding the visual world, simulating the world, making content for content creation in Adobe, etc., etc. All of these, they are not code output, but visual output, visual input. And I think it's like also important to not forget that there's like these additional frontiers, and the capabilities and these new frontiers, they are just being unlocked. Like we started with like text-to-image, text-to-video generation, but we are now seeing a trend towards, especially in combination with real-time applications, real-time models, towards like deploying these models in physical AI, in robots. And I think that's super exciting, and then it unlocks like a whole new field of like, I want our video models to power manufacturing, right? And I think that's pretty exciting. That's a new frontier, and it's also like interesting to think about how can you have agents interact with these models? How can you like expose control parameters that are good for like an agentic interface?
So first of all, I want to say, I do want to respond to that, but first I want to say you asked us to treat it like your living room, and usually it's really hard to get people to get in a living room. I know. So one, I just wanted to say, can we give Jensen like a huge round of applause for just getting us all together? It is insanely hard. There are people here from multiple continents who made it possible. So thank you for bringing us together. I think the thing that Robin just said, which is super important, you may have missed Arthur say it, and I think you're being a little unfair to Arthur, because what I've learned about Arthur over the years is he's French, but he's also a mathematician. You got a PhD in math.
I do, yeah.
And so usually it's sometimes hard for those.
He's insanely smart, just incomprehensible.
Exactly. If you asked Arthur to explain where the world is going in math, it takes the rest of us a little bit to catch up, but it usually is right. And so maybe next time we'll let him whiteboard a little bit or something. But what Robin said is very interesting. He said there's many frontiers. And I think we need to remind the world about that a little bit. Because right now, I think we're all gripped a little bit by the extraordinary nature of progress in coding. Oh my God, these models, they're incredible at coding. Like, aren't we going to, is this it? Are they going to take over everything? And I think we should actually be super excited, because actually the lesson we should be extracting is similar to what you pointed out, that the bitter lesson is holding. 4 years ago, when Dario and Tom gave me a call, old friends of mine, and said, Anj, we've just published this paper called GPT-3, and we want to leave and start a new company called Anthropic, and can you help us out? And then we made 22 introductions for them up and down Sand Hill, and 21 people said no. Nobody believed that the bitter lesson held. And 4 years later now, we have proof that not only does the bitter lesson hold, but that it's a predictable revenue scaling curve. That revenue scales predictably with compute. And I think what we need to be excited about...
Did you guys just hear that? I don't want to interrupt, but I just got to say that. It's revenue scales linearly with compute. The more you buy, the more you make.
I'm one of...
Put it out there.
Go ahead,
Anj, I'm sorry.
Your product. but I think what's getting lost is in that coding is just the first bitter lesson evidence.
Yeah.
That's legible to the world on revenue. Mistral, Black Forest, Open Evidence, these are all new frontiers where revenue is scaling with compute. And so we got to remind ourselves that the real thing that we've discovered in the last year is that the bitter lesson holds, revenue scales with compute. But yes, that's hard to do. Scaling compute, turns out, the bitter lesson says, for frontier progress, scale compute. It doesn't say how you should scale compute. And it turns out that the best unit of independent innovation, frontier innovation, is a small, sometimes large, but focused, talent-dense team with access to enormous compute. When I look across here, what I see, and I see with the Nemotron team too, is focused, talent-dense teams with access to enormous compute. So what do? To innovate at the frontier, you try to scale compute. And that, it turns out, is really hard to do without help from people like you. So one, thank you. Because it's really hard to scale something that's not fungible. And I think that as long as we understand that what's happening is that we are discovering all these new frontiers, and OpenClaw is just one of them, where agentic progress will continue if we can get the right people to compute without ruining the thing that keeps the progress so fast, which is the talent density of these teams. Then I think we're going to keep seeing more and more of what you described.
Yep.
First of all, I want to defend Arthur over here because...
You understand his French?
I don't, but listening to it, everything he says in that accent is profound.
Exactly, I know.
He could read the back of a cereal box in that accent, and I think he should go for a Nobel Prize. It's really profound.
I'm with you.
You asked about industry-specific applications, which is, I suppose, my role on this panel. So, what are these claws, these agents, whatever we want to call them, whatever metaphors we want to use, really good at? They're good at many things, but one thing they're especially good at is multi-step repetitive behavior where the steps are predictable. And as valuable as that is clearly in coding and in programming, that paradigm exists in every industry in the United States of America. And it very notably exists in healthcare. Most people's mental model of what a doctor does is they arrive at a diagnosis, make a treatment decision, write a script. That's part of what a doctor does. Most doctors wish that were the entirety of what a doctor does. A lot of what a doctor does exists on either side of that, bookends to that, involving, especially in the American healthcare system, and the structure and nature of the American healthcare system, writing things called prior authorization letters to insurance companies to essentially ask for permission to write this patient a script. And when the insurance company denies it, as they unfortunately often do, writing a appeal, writing an insurance denial appeal, and many, many other types of paperwork that exists as sort of sub-steps of that. Those tasks are perfect for multi-step agentic systems because they involve what you talked about, sort of private, secure information, in this case, private health information involving a specific patient, which needs to be protected. It's protected health information. It involves, though, templates, the templates that exist in prior authorization letters that you would want to deterministically fill out on the basis of that information. And then it can take action while the physician is sleeping. So let's say the physician is sleeping and their patient has been denied that drug. Well, instead of waiting for that physician to wake up the next morning and they have 400 other things to do, you can imagine an agent responding to that insurance denial with an appeal and pulling from that patient record additional information that the insurance company is looking for to then appeal on behalf of that patient, ultimately, on behalf of the doctor, on behalf of that patient, to the insurance company to ultimately get them what might be, a critical or even life-saving treatment. That is the scale of the impact that these systems can have. And I think a lot of people who are not coders, when they listen to some of this stuff, they immediately go geek in their head, and it's like, okay, I get why this makes programmers better programmers. But you have to understand this is every industry in America. It's healthcare, it's law. All of these industries follow this paradigm of needing this sort of multi-step agentic behavior.
Yeah, one of the things that we all believe in, and we ought to spend some time talking about this, is the importance, and I would even go so far as the criticality of very high quality open models. And it's not a model, it's a whole bunch of different types of models. And oftentimes when people talk about AI and the regulations of AI and the applications of AI and the AI industry, it always goes back to a couple of 2, 3, 4 different companies. And the reason why we're having this panel, the reason why you're in my living room, really is really to talk about, in fact, the 90% of where AI will largely enrich society, ultimately impact the various industries and the various ecosystems of companies and various countries around the world. Open models is really quite an essential part of that. And whatever it is that we do as we celebrate the advances of AI in the most advanced labs, and I'm super happy about all of that, is not to take our eyes off of the importance of open models. Could you guys all talk about the importance of open models to you and your own industry, and why it's important, and what are the things that you might consider that we should all know about to not diminish, not extinguish its ability to thrive?
Well, open models is how we got known with Mistral 7B in 2023. And effectively, we started Mistral to create an enterprise business on top of an open model foundation. And we've been lucky to work with you and Mistral Nemo, which was a 2024 release, which was quite good. And the reason why we believe that open weight models should actually be the basis for building all AI software in the world is really two things. The first is control. Because AI agent sits at the execution layer, you want to have control over where this gets deployed. You want to make sure that you have the turn-on button to all agents that you're deploying in your company. And so if you actually own the systems entirely, so from the models to the orchestration layer, and you know what code is actually running and you can actually modify it, suddenly you're much more confident than if you're depending on only APIs that can be turned off or you can fall into certain problems. So that resilience is actually very important. The second reason is really customization. Agents are great when they're operating in the virtual world, where they're operating on knowledge. They're great on healthcare because they see a lot of documents. But whenever you have something where you have a physical footprint, you have a machine, you want to model a physical system, you have an engineering team that needs actually to build things in the physical world, well, suddenly you have a lot of IP that you want to put into the models themselves, and it's never going to go back to the general purpose models that are trained fully on the virtual world. And so if suddenly you have access to models that you can modify, to whom you can plug time series stream, etc., you can actually build agents that understand the physical world and actually make them useful for teams like engineering teams that currently do not benefit a lot from generative AI. So I think that customization aspect, we've released a product called Forge that is precisely meant to connect models to various sources of data that may come from the physical world, is the second reason why open models are very important. And I would say, finally, open models are great because it allows to make cheaper versions of everything. By working together, by sharing R&D cost, that's the Neomotron coalition that we're happy to be part of, by having an open ecosystem of people that have aligned incentives to create assets that are going to be great for humanity, we can actually accelerate progress and make sure that everybody gets access in a fair way across the world to artificial intelligence. And so that's why I think it matters a lot.
Yeah, that's true.
They're uploading my French accent.
They understood you.
Yes.
No, I think they were just thrilled that they're getting used to you. Yeah, you do have to listen to Arthur for a while. Yeah.
The RL is working.
The cold start doesn't work with Arthur. Okay, go, guys.
So to me, open models are the requisite foundation of specialized models, right? You can't sort of think of them separately. And the reason open models are important, you have to go to what is the limitation of closed models. And one way to think about large closed models, trillion or multi-trillion parameter closed models, is they're like an 800-year-old parent, okay? They've been thinking and reinforced along a certain vector for a very, very long time, 800 years, many epochs. And they're very good at seeing the world the way they see the world, but if you want to try to get your 800-year-old parent to see the world any differently than the way they see the world, that's going to be a tough political conversation. That's going to be a tough whatever conversation. And these trillion parameter closed models are like those 800-year-old parents. They're very good at what they've been reinforced to do. I think Open Evidence thinks, and a lot of these companies up here think, that the shape of AI in the future is going to reflect the shape of society. So what's the shape of society? Society is actually quite specialized. Whether we like it or not, the reality is society is specialized, and it's going to continue to be specialized. a corporation, our companies here, they're quite specialized if you think about it. You have the CEO or the founder or the entrepreneur whose job is sort of thinking very ambitiously and optimistically, and you might have a general counsel in your company whose job is reining Jensen in and saying, well, there's some risks if we say this, and I don't know if we should say that. And if you think about it, both of those roles...
that's not working.
It's exactly how it works. I just got someone with that role in my company. They're phenomenal at it, but that's what they're good at doing. Now, what would the alternative be? The alternative would be one person having an average of all those intelligences. And I think someone having an average of all of those intelligences would be a very average intelligence, right? Someone who sort of half thinks about risk and half thinks about opportunity, but is not really optimized for any of those things perfectly, is going to be a very middling kind of character. And so that's why you have to sort of shape AI the way you shape society. And of course, in my industry, hospital systems are already built this way, right? In hospitals, you have generalists, but what makes some of the best hospitals in America so great is they have a world-class cardiologist who always sees things through the lens of the heart, and a world-class neurologist, and a world-class oncologist. And that's the way that society, in its sort of wet brain form, has decided to organize itself. And I think the shape of AI is going to reflect that, and it's going to involve digital twins of that neurologist, digital twins of that oncologist. And in order to do that, you can't start from these 800-year-old models that are already set in their ways, that are sort of set to think about pattern recognition that's down the middle. You actually want the tails, and you want to train in the tails, and open models are that sort of requisite foundation for that.
So I want to add to the control and customizability of what Arthur mentioned to another concept, which is when we have a language model or an AI system, these days we just look at the final snapshot of this whole very long curated process of how these models are developed. However, I argue that there is a long process, and releasing different parts of it, enabling researchers and developers use different parts of it, it enables infinite customization, not just a final weight, but also on top of different checkpoints of the model. So my team built Olmo, and through that, we developed model flow, which we call it the full development cycle of the whole process, including the data, all the model weights, all the infrastructure and everything, so that researchers and hardcore developers could actually play with it, integrate their finding, and even build on top of that. So why is this important? So this is particularly really important to make advances in the next generation of AI, because these days you might argue that progress in AI is getting limited into a few closed labs. But it's actually very important to the vast majority of academia and researchers or kind of nonprofit and other places who want to also be part of this progress. And we've seen that this progress already has happened by everything being open. So for example, you've probably all seen that hybrid models are being used in many of these open models and even closed models like Nemotron, a very good example of that. So most recently, our team started releasing and studying why hybrid models are probably only better than only transformers. And based on analysis and more theoretical findings, we actually found that, okay, there are theoretical reasons why hybrid models are better. And then empirically, we show that, yes, it actually is much more efficient, much more token efficient in training. So having access to this infrastructure, training, and being able to kind of publicly talk about it and also kind of study these models enable the next generation of even model architecture, better AI systems, and so on. So enabling research is also a very important topic.
Yeah, 100%. I think open models are strictly better than closed models. I think they enable diffusion of innovation, research, and competition. And I guess competition in the end is good for you, right? And in addition to that, it's really also, I don't know, I'm here in Silicon Valley, every 2 months, then I'm based in Germany for my usual day-to-day work. And I come here now, and there's this weird AI psychosis going on, where people, even AI researchers, think that they cannot really contribute anymore because of the advances in coding agents and stuff like that. But I think even if you're really convinced of that, then the way that you can have impact should be thinking about how can I make an open model that actually can replicate these capabilities. So I think like it's actually one of the like most exciting times to work on either like the frontier models, the big models, or more specialized open models that then get deployed like on device and all of that. And there's like so many different frontiers, and all of them should have like some open component. I think from like a business perspective, it's probably interesting to figure out if there's like licensing models where you still have the model openly available, but figure out some license that also allows you as a company to benefit from that commercially. But besides that, I think like open models provide all of this like customization and flexibility that they should be strictly
Robin,
preferred.
even if I could just add this, even in a company that is a closed model company, I really believe that open models will be used as part of the agentic system where the closed model is your crown jewels. And I'm fairly certain that even in visual intelligence, that used to be text to image, in the future, well, you're already there now, increasingly, it's an robotic visual intelligence system. And so it's reasoning, it's taking inputs, and the prompts could be text and many other conditionings. It's solving problems and ultimately generating an image or a stream of images that you can even interact with in a very robotic way. And so I think the future of visual intelligence that you're working on is just so exciting. And even though it's a proprietary crown jewels today, you're going to surround it with a whole bunch of open models. Is my prediction. Yeah, go ahead, Anj.
I actually, at the risk of contradicting you, I'm going to say I disagree with you on one thing, which is you said open models are strictly better than closed models. Because I actually think in some contexts, closed models are great, but there is one context in which open models are extraordinary. If you think about all the applications that you guys just mentioned, they're increasingly mission critical. Right? You talked, Arthur, about logistics and a bunch of military or defense or critical national applications. Daniel, you were talking about healthcare, right? And you were talking about university research, and you talked about visual intelligence, which can be used in all kinds of things. 3-4 years ago, I think the questions we often used to get is, will AI be useful for anything more than chatbots? And now, because of RL and agentic infrastructure, these are getting useful at mission-critical applications. And the thing about mission-critical applications is you got to trust that they will perform the way you do in a high-stakes situation where the margin of error is very low. And the reality is, if it's not an open model, and you don't control where, you don't know where, you can't introspect it, you can't host it, and you're dependent on third parties for that, hey, they're good at some things. But at the end of the day, you're delegating trust. And I think that'll become more and more a topic of conversation as those of you who are deploying agents in critical industries, I think it'll come back to trust. And it's much easier to trust an open system that you can introspect, and you can say, look, parts of this system are closed and it's good at that, I'm going to deploy it, but I'm going to have some guardrails, and I'm going to manage the risk. But at the end of the day, especially in healthcare, defense, places that run, if we want to welcome these agents into the most mission-critical parts of our lives, I think we're going to have to find a way to trust them. And as far as I know, open models are one of the fastest ways to trust a system.
Yeah.
Now, the flip side is, I think the infrastructure also has to be open. And that's not happening as quickly as it should. We are heading into a phase of the industry where infrastructure is consolidating very fast. If you study the history of the Industrial Revolution, you asked us to consider the industrial applications, and I think we are in a new era, but there's some clues that the 1800s gave us where if you looked at factories that had a steam engine and knew that you could make interesting products, they were starting to realize that, hey, the inputs to production are pretty critical. And they started hoarding them. And if you just do a flyby of 1800 Victorian England, you'll see factories with generators running at half capacity because everyone's hoarding generators and trying to run their own generator. And you have piles of coal just stockpiling, not being used. And I think what we need to go to is open models and open infrastructure. We need to develop a mechanism that allows us to share, not to over-provision for peak, but have enough secure infrastructure that we get our base load, but then we can spike up and down. And that's called a grid. That's what we're working on at AMP. Yeah. As you know, we're building an AI grid, but But I really do think for open models to be developed at the frontier, we're going to need open infrastructure too.
Yeah. Well, the concept of a AI factory foundry is really, really important. And I think that this year, I think we're going to start to see the emergence of that kind of idea so that companies don't have to be gigantic in order to be able to afford or be able to secure capacity of compute. And so I'm really hoping that there's a flourishing industry where you called it open compute, but computing is available for companies, large, small, researchers, and otherwise. Now, one of the things that all of us are working on is, of course, recognizing several different inflections. The first inflection is the era of agentic systems that are able to solve some very interesting problems, and OpenClaw is just a wonderful event that is happening. The second inflection is the convergence of very capable models with these agentic systems is now helping us create solutions, platforms that are incredibly valuable to enterprise that Arthur's focused on, Daniel's focused on healthcare. You've got Martin focused on visual intelligence and media, entertainment, robotics. And so all of these different industries are starting to get solutions that are very impactful and very capable. And so I think that this year we're going to see really, instead of the question, what is the ROI of, the last 3 years, all of the questions are, what are the ROIs of AI? I think now we're going to, this year, starting with coding, of course, and coding is not just software engineering. Coding is the description, the codifying of business processes, codifying basically the rules of all businesses and all engineering and almost all work. And so coding is a very big deal, but nonetheless, we're going to see an inflection this year of real business economics taken off, and you guys are all experiencing that. Ladies and gentlemen, hey, let's get the last crew back up here. Where are they? Give them come on, you guys, hurry up. Come up here, Arvind. This is the next generation of the world's great CEOs, and I love working with this crew. And you guys see why they're, leading such impactful companies. And these are the shapers of the future of the world's industries. Ladies and gentlemen, my good friends. Are we posed right? Are we standing right? They're taking pictures. We gotta look good. No, hang on a second. We gotta look good, guys. All right. That's it, the future. Thank you, guys. Good job, Daniel. Arthur, good job. Arvind, good job.